Okay, this is the second part in the three-part video on turning effect of forces. In this case, we are talking about, in this video, the principle of moments. Let's recap. In the first video, we talked about moment of force and how we can find it. The second one is what is the principle of moment. And lastly, we would like to talk about some sample questions on principle of moment. So in this particular video, we're going to tackle the second item, which is the principle of moment. So let's define principle of moments. Principle of moment states that when a body is in equilibrium, the sum of the clockwise moment is equal about the pivot is equal to the sum of the anti-clockwise moment about the same pivot. If you are asked to define the principle of moment, those underlined are the keywords. You cannot leave any of these keywords out because it will not make sense if any of these keywords are missing. So in order to understand the principle of moments, let's look at a case where you have only one force acting on a seesaw. Now, if you have only one force acting on a seesaw, obviously there will be a resultant moment about the pivot. Okay, what will happen? Okay, obviously the seesaw, of course it can't rotate so much, but the seesaw will basically rotate in a clockwise direction. If it can, it probably will rotate the full circle. All right, so that is how what will happen if there is resultant moment. But what happens if you have an equal force placed at an equal distance away at the opposite side of the seesaw? What will happen? Now, if you do a calculation, you realize that the clockwise moment is 5 times 2. The anti-clockwise moment is also 5 times 2. So if you subtract these two moments because they are in the opposite direction, you get 0 Newton meter. So it means that there is no resultant moment, and because of that, the beam is at rest or in equilibrium. Okay. So when the beam is in equilibrium, we know that the clockwise moment minus the anti-clockwise moment equals no resultant force. So in that case, the clockwise moment minus anti-clockwise moment equals 0. Okay, the Newton meter is just the unit. So if you rearrange the formula, you have your principle of moments. The principle of moment states that the clockwise moment equal to the anti-clockwise moment about the same pivot when in equilibrium. All right, so that's how it arises, how the principle of moments arises. So let us deal with principle of moments by doing a few examples. Now look at this question. Okay, if you are trying to solve any principle of moment question, you must write down the statement. You must write down by the principle of moment, total clockwise moment equal to total anti-clockwise moment. So if this question is asking you to find the unknown D such that the beam is balanced. All right, so how do you find? So the total clockwise moment will be what? The total clockwise moment will be, okay, let me just turn on my pen. Okay, the total clockwise moment will definitely be this guy here, which is 30 times D, and the total anti-clockwise moment will be this one here, which is 10 times 50, right? So because of that, if you solve it, you get 16.7. So that is your answer, because this moment must balance this moment for the principle moment to exist. That's why for the principle moment to be true, that's why the unknown D is equal to 16.7. You can solve it by using equation. Now, second example, what if in this case there are more than one force? There are two forces here and one F here. So how do you find the unknown F? In the same way, first of all, you need to write down the statement. After you written down the statement, okay, you know that this 15 Newton and this 5 Newton both are clockwise moment, right? So you have two clockwise moment and one anti-clockwise moment. So you need to sum up all the clockwise and all the anti-clockwise moment. So both the clockwise moment will be 5 times 10 minus 2. Then you say, why is it 10 minus 2? Remember, the distance d has to be the perpendicular distance from the force to the pivot. So it has to be this distance, which is 10 minus 2 or 8 cm. So this is 8 cm plus 15 times 10. Alright, so this is sum of two moments equal to F times 4. So you'll get 47.5. Okay, so let's move on to the next one. How about this case? You have a body that is very strange shape. Does it matter whether the shape is strange or not? It doesn't matter. The principle of moment will still apply. But in this case, you need to be very careful. You need to identify which one is your clockwise and which one is your anti-clockwise. Now for this one, obviously this will be your anti-clockwise, right? But this one is harder to see. How do you know this is clockwise? Okay, although this force is acting in this direction, if you just imagine pulling this rigid L-shaped thing in this direction, you will still rotate downwards. So because of that, this is still a clockwise moment. Now the only hard part is that for this 8 Newton force, what is the perpendicular distance? Okay, remember your first video, always extend your force, the line of action of your force, and then draw your perpendicular distance. So this will be your perpendicular distance, and because this distance is the same as 0.1, you can use 0.1 directly. Alright, so this will be your perpendicular distance for the 8 Newton force to the pivot. So writing the statement down again, your clockwise moment will be 8 times 0.1. Your anti-clockwise moment will also be F times 0.1. So F is obviously 8 Newton. Alright, so let's look at this question. Alright, I think probably is the last question already. Okay, how do you find the unknown force F if it is balanced? Okay, so in this case, it's a little bit more complicated. Again, you need to be careful. You need to find the perpendicular distance. So first of all, also you need to know which one is clockwise and anti-clockwise. This will be a clockwise moment. Why? Because this is a rigid body, and you're pulling the rigid body down in this direction with the rigid body pivoted here. So imagine this is a disc, and then you pull at this point. Alright, obviously it's going to rotate clockwise. Now if you have a F that's in the center and you're pushing in this direction, obviously it's going to rotate anti-clockwise about the pivot. Alright, but then what is the perpendicular distance of these two forces? So in the first case, again we draw the line of action, and then you realize that the first perpendicular distance is the 3 cm for this guy. Alright, similarly you draw the line of action, you realize that this 4 cm is for this guy, this force. Alright, this one only you draw because it's already at that point. Okay, so by taking principle of moment, again the statement, the clockwise moment 25 times 3 will be equal to F times 4. So F is 18.8. Okay, so this is really the last video, last slide. In the next video, we're going to deal with much harder examples so that you'll be able to answer any form of questions in principle of moments. Alright, so that's all for this video. Thank you.